the sensors for like if we find like obstacle avoidance or precision landing, so there the sensors comes into the picture. These are the basic components like to build a basic drone. Now we can see the types of the frames. The types of the frame will depend upon like how you are placing the flight controller. If you are placing the flight controller at center, if it forms a plus structure, so then we call this a quad plus. So when you are uploading the firmware, you have to upload the plus firmware. So again, if you place the flight controller in cross shape, then you have to upload quad X. And if you are placing in quad H, then you have to upload quad H firmware. Similarly, like hexa plus and hexa X, and octa plus and octa X, and octa X8 is like a similar to quad X. Then there will be four motors bottom of the quad X, like a pair of motors in one side. And next is like now we are now how what are the forces acting on your drone. The simple thing is, if anything has to go up, it has to generate a thrust more than its weight. So the gravity will pulls the object down. So the if the drone has to take off, the required thrust should be more than the gravitational force. So here upward force is lift and the downward force is gravity. So in coming to the drone, there are four controllers. One is for throttle, which helps to increase the speed of the motors and decrease the speed of the motors for lifting up and lifting down. And the next is roll. Roll is like moving the drone right side and left side. And pitch is for moving the drone forward and the moving the drone backward. And the yaw is rotating the drone in at the position where it holds. It has to rotate clockwise and anti-clockwise. Like drone will be stationary, but drone will rotate in clockwise and anti-clockwise. That movement we call as yaw. And right and left movements are called roll. And the forward and backward are called pitch. I hope you all understand the terminologies: total, yaw, roll, and pitch. And next is how to control a drone. Like basically, let's consider a quadcopter, which consists of a four motors, and that motors are controlled by the ESCs. In first picture, it shows about throttle. So if you run the all motors at the same speed, if you increase the speed, the drone will take off from the ground. If you are increasing still, the drone will still going up. So once you start decreasing the speed, the drone will descend towards the ground. So in second picture, if you see that red symbol indicates high speed and the green symbol indicates normal speed. If the backside motors of the drone run fast, then the drone will move forward. If the front two motors are run fast than the back two motors, then the drone will move forward. Like here, move forward we call as a pitch forward, and move backward we call as pitch backward. I hope you all are understanding. And coming to the third box, roll. Roll. You can see the picture first bend left and bend right. Like if the right side motors are running more speed than the left side motors, then the drone will move left side. If the speed of the right right motors running speed, then the drone will move left side. If the left side motors are running at high speed than the right motors, then the drone will move right side. If the corners motors are running at high speed and the opposite corners are running at slow speed, then you can get a motion of yaw, like it will rotate in one place, either clockwise or anti-clockwise. I hope you understand about the controls: throttle, pitch, yaw, and roll. If anyone has any questions on up to this, you can ask. Feel free to talk and be interactive.
Guys, like yesterday's session, you will be more interactive. You can ask questions. Like he's asking, like Rathod Rahul is asking, what is the difference between Quad X and Quad Y? Literally, both are same.
Quad X and Quad Y.
Yeah, I think it
Yeah,
is called X and Quad V. I think so.
quad.
X and Quad V.
Yeah, quad X and quad V, like there will, like in quad X, the angle between the two arms will be same. And when you
Okay.
come to the quad V, the angle between the backside two motors will be less. Like front two motors will be more and backside motors will be less. Like it looks like a DJ drone. If you see a DJ drone, front arms will be more and left backside arms will be close. So that we call as a quad V structure.
Okay. Next, any questions? Guys, try to be interactive. Mm, okay, Rahul. Okay. Mankanda, you can continue forward, like
Yeah, yeah,
take
sure.
session forward.
And now we know that how the drone moves forward, backward, and right, left, and rotate. Now, before building your drone, like you need some calculations or how to select a motor for your drone, how to select your frame, and how to select your ESC for the drone, and how to select the battery, and how you will calculate the flight time. And now we will going to learn that things. First, we will go with how to select a motor. Does anyone know about how to select a motor for your drone?
Guys, do
Okay,
respond. No, no.
okay. Let now I by the end of the session you will calculate by yourself for your project or anything. Let me share this screen. How to select a motor for you. I am taking this motor as a reference, which is MN 5008 anti-gravity 612S and the KV is 340. So how to check the specifications of a motor and how you will select that motor. So now we will go to specification page. Here you can see that what are the main things you require when you open a data sheet of a motor. First, you have to check that kV of the motor and the rated voltage, like how much voltage it will hold. And here you can see that ESC recommendation. And this is the name of the ESC which is suitable if you choose 170 kV motor. If you scroll down, here they will provide you a test data. So here the motor name is MN5008 and 170 kV. And here the propeller, they are choosing 17 cross 5.8. Here 17 is the length of the propeller in inches and 5.8 is the pitch rate of the propeller. And here you can see at 40%, like when you are giving a 40% PWM signal through your from your remote, so it can take 1.17 ampere and it will take 55 watt per hour and the motor will run at 2868 rpm and it will generate 682 grams. So for to maintain a stable drone, the overall thrust generated by the drone should be double the weight of the drone. Let's consider if your drone weight is 2 kgs, then you have to find a drone which can lift the 2 kg weight at 50% throttle. You can see that 50%. Here it is generating 1.1 kg. So let's calculate for this one. Like if you have 50% throttle and it is 1058 grams. So let me open a simulator which we created. Like here is a simple script which will calculate the thrust generate thrust required. So here let's consider number of the rotors like it is. Let's consider we are building a quadcopter drone. So the number of rotors it will be 4. So enter the 4 and enter. Here is asking enter the thrust generated by a motor at 50% throttle. Now you can see here the 50% throttle. it is generating 1.058 kg thrust. Now you can type 1.05. So once you click enter, it is showing that total thrust generated by the four motors is 4.2 kg. So if you are using this motor with 17-inch propeller, it can lift up to 4.2 kg stably. It can lift 5 kg, but it will not be stable. To get a stable flight and the good flight time, the maximum weight you can get keep up to 4.2 kgs for your safety operations. Now we will go for how much flight time you will get if we use that motor as a reference. How much flight time you will get? Let's run this code, and here it is asking number of rotors. We are using quadcopter. Now enter 4. Now it is asking enter the power drawn by the motor at 50% rotor in kV. So if we see at 50%, the power is 100 watt. If you want, if you convert this into kilowatt, it will become 0.1 kilowatt. So just enter 0.1 kilowatt. Now it is asking the voltage of the battery. So here you have to select a battery. Now let's say example, you are using 22,000 mAh battery and its voltage is 25. So if you are entering the voltage which is 25 volt and it is asking AH. AH is the capacity of the battery. If you are using 22,000 mAh, then when you are converting into AH, it will convert into 22. Like we have to divide by 1000. Now I am at 22. Then it is getting 82 minutes of flight time. So by this, you can calculate the estimation of your flight time of the drone. Uh, now, now you have the total weight of the drone, but you don't know what motor to choose. For that, here first you have to think how many rotors you are going to use. Like if you are going to use hexacopter, then you have to enter 6. If you are using quadcopter, then we can use 4. Let's take now as a hexacopter. I am entering the number of rotors 6. Now here is asking enter the total weight of the drone. Let's take our total weight of the drone with the battery and everything is 20 kgs. Now it is asking check in the motor data sheet. It has to generate 3.3 kgs at 50% throttle. Now you have to find such a motor that it has to generate 3.3 kgs at 50% throttle. Then this motor is not suitable for lifting 20 kgs payload of drone because it is generating only 1 kilogram at 50%, but we required 3.3 kg. I hope you all understanding. Hello.
Yeah, Manikanta. Yeah, Manikanta.
Yeah.
Yeah, there is a response.
Hmm. If you have any doubts, we will calculate again. Let me know in the chat. It is very important that to calculation, like we have, like if any drone you.
You are muted. Manikanta, you are muted. Can you please unmute yourself? Guys, I think there is a network issue. Let him come.
Hello.
Yeah, Manikanta.
Sorry for like if you are think they will payload it will lift
Your
and
voice is
flight
little
time can expect
like
from this. So let me know.
okay. a slight breakage in your
Hello,
voice. Like it is not clear. Your voice
hello,
is not clear. Yeah, yeah, Manikanta.
hello.
Yes, Manikanta.
Yeah, if anyone has any doubt, you can ask again.
Okay. Your video is fast.
1 minute. Hello,
Yeah, yeah, Manikanta. Now it's completely visible.
hello.
Yeah, Manikanta, you are audible.
Hello.
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 Yeah,
Yeah,
Manikanta, you
audible.
are audible. Yeah, yeah, you are audible. You are audible.
Yeah, yeah. I will explain that application software in controlling the drone, and it's like
How much
I
will
will.
it cost
Can you show the live? Hello.
now for? Yeah, yeah, yeah.
Yeah, can you show the live now the functionality? Yeah, I will simulate a drone for you. How does the drone maintain stability while flying? Like the brain of the drone is like flight controller, which controls the dynamics of the drone. So that has the sensors, accelerometer, gyroscope, and magnetometer. So based on sensor fusion technique that combines the data coming from the different sensors in the drone, and it will maintain the stability of the drone by adjusting by changing the speeds of the motor.
Okay.
One-
Hope they get the answer.
Now let's go to presentation. Now you got to know how to choose a motor. I hope everyone can select their motor for their applications. Now let's go to how to select right ESC for your drone. Like if you now first thing is you choosing the motor, but you don't know how much ESC you have to take for your motor. Let's go to that ESC. Here only you can check like if you are choosing this motor MN5008 kV 170. First you check at 100% how much current it is taking. It is taking 11 amps. So try to take the ESC which can be approx 20% more than this one. Mostly the manufacturer will recommend you how much ESC you have to take for safety purpose. Here the motor is same, but you are taking 17-inch propeller and 18-inch propeller. But in 17-inch propeller, it's taking only 11 amps of current, but in 18 amps, it is getting 14 amps of current. Similar motor, if you go with 340 kV, it is taking 26 amps. So they will check at max how much it is taking. Here it is taking 32 amps. So based on that, the manufacturer will say that 60 amps is recommended to you if you are using this motor, because for one application you can use 17-inch propeller and other application you may go to 18-inch propeller, but every time the ESC you have to change. So due to that, the manufacturer will decide the maximum current drawn by the motor, if that is 32 amps. So here they will recommend 20% more than this one. So it will be around 45 or 50. So that's why they will recommend to you to use 60 amps with the 12S. 12S is like a 12 cell battery. This 12S determines the battery. S is like series. So here 12 batteries are connected in series. So each battery is 4.2 volt max. And if you multiply it by 12, and it will get around 50.2 volt battery. So based on the specifications, you can select the right ESC for your motor. And next is a battery. So the main battery you have to check is based on the motor. Here they mention 12S and here rated voltage is 6 to 12S. So here the motor can operate from 6 cell battery to 12 cell battery. So when you go to battery in specification, they will mention 6S. Here it shows that 6 cells are connected in series. So here it will like minimum voltage is 22.2. Like each cell has 3.6 volt and combining 6 cells in series, the voltage will add. So it is getting 22.2 as minimum voltage and the maximum voltage will be 4.2 into 6. Then it will be around 25.2. Here this 5200 it shows as the mAh like capacity of the battery and the 35C is C rating. It determines the discharge rate of the battery. So like drone operations, like heavy load drones, and it should be 25 or 20, more than 25. When you are coming to racing drones, FPV drones, it should be around 100C, 200C because it runs RPM at motors at high speed. So it will draw the current more at a time compared to these drones. So now you selected the battery. Uh, let's go to the code for calculating the required power, like how much battery you have to keep. I'm running this. Here it is asking, now this we will calculate by the participants if they text in the group, like what is the total weight of the drone they are planning. Someone from the chat, they can start. How much total weight of the drone you are planning to build? Please respond in the chat.
Guys, try to be make it much more
Yeah,
interactive.
Bal Manikanta, 1.25 kgs. Okay, 1.25 kgs. So number of motors you are going to use. You need quadcopter or hexacopter. Four. Okay, good. And here enter the thrust generated by the motor at a 50% throttle. So now if we are using this motor, so here it is asking enter the thrust generated by the motor at 50% throttle. Enter the thrust generated by the motor at 50% throttle. It is 1.05 kg. 1.05. It is asking enter the power drawn by the motor at 50% throttle. It is taking 100 watt. If you convert this into kilowatt, it will get 0.1. 0.1. Here it is asking how much flight time you are expecting. Please respond in the chat. How much flight time you are expecting in minutes. Okay. There are multiple answers. So let's consider 15 minutes or 30 minutes. So let's consider 30 minutes. Here it is asking enter the voltage of the battery. When you go into the trust data sheet, here it will show 12S. 12S, I said 50 volt. You have to enter the voltage as 50, enter. It is showing that your required power is 0.2 kilowatt. So your battery has to provide 0.2 kilowatt power to give you a flight time of 30 minutes. I hope you understand like how to select a battery. Here this 0.2 is like when you are going to battery, you have to multiply 5200. It is in milliamp per hour. You have to convert this into ampere hour. by dividing by 1000. So you will get around 5.2, and you have to multiply this 5.2 with this 22.2. Then you have to get it as 0.2. I hope you understand how to select the battery. Hello.
Yeah, Manikanta.
Yeah, here you can see that now we calculate from here only. Here the battery voltage is 22.2, and if you convert this 5200 mAh into AH, then that will come 5.2. So it is generating 115.44. So this battery is sufficient for this drone, which you are carrying 1.25 kgs of drone. Now you got the required power, and you calculated the power generated by the battery. It is 22.2 into 5.2, that is 115.44 watt. Now from that, mm, now from that we will get, like, we required is 0.2 kilowatt, but we got 115.44 kilowatt. But with that power, we need to calculate the flight time. Previously, we calculated for 30 minutes. Now we have to check if we are using this battery with 115.44 kilowatt. So we will check that whether how much flight time we will get. Now here it is asking number of rotors. We use quad 4, and the power drawn by the motor at 50 kilowatt is 0.1. And here it is asking enter the battery voltage 22.2. It is asking enter the AH of the battery. Here the AH of the battery is 5.2. It is getting 17 minutes of flight time. So then if you are required this one, 115.44 is in watts. Now you have to convert this into it is in milli. So you have to divide this with 1000. You are getting 0.115, but you are required is 0.2. That's why you are getting less time than you expected. Here you are expected 30 minutes flight time, but you are getting 17 minutes only. The thing is here the power required is 0.2 kilowatt, but you are giving only 0.11. So that's why your flight time is reduced. I hope you understand. Okay, I will explain again. Here the uh, battery voltage is 22.22, and the mAh is converted into AH, that will be 5.2. You will get 115.44. It is in watt. You have to convert into kilowatt. So you have to divide with 1000. So you will get 0.115 kilowatt. It's like this much power your battery can provide. Is this part is clear? Hello? 0.115 is the battery capacity that battery can provide. So here when you calculated before for 1.25 kg, when you're using quadcopter, it's required 0.2 kilowatt to get 30 minutes flight time. But you are providing only 0.11. So that's why you are getting only 17 minutes flight time. So that's why there is a gap of around 12.5 minutes gap. Hello? Is you understand? Please respond in the chat.
They are responding through emojis. You can look into that. As of now, they are flashing. Guys, do respond.
Like here they are asking weight for change to weight for 600 grams. So let's calculate again that first we will calculate for thrust required for each motor. Here they are asking about
Weight.
uh,
Weight need to
change
be
the
changed to 600
here
grams.
600 grams is the whole weight of the drone. Let's consider. So here if you plan for quadcopter 4 and the total weight of the drone is 600 grams. So that you have to convert into kilograms 0.6. Here it is asking check in the motor datasheet. It has to generate 0.15 kg at 50%. Like it is getting, it has to generate at 50% is 150 grams. So you have to check the motor which has in place of 50%. Here it is 1.1 kg. So you have to choose which motor which is giving 150 grams. So in place of 1058, the motor should has 150 grams. So then you can choose that motor as your for your project. I hope you understand for this 600 grams. Hello? Okay. Now let's go. Now we up to now we do with how to select motor, ESC, and battery. Now let's go to the flight controller which we are using for drone. It is a Pixoc 2.4.8 is a basic controller for hobbies and for initial stage for learning. Here you can see the fast pen which is called Spectrum DSM receiver. Like it is a type of receiver for like you have an RC remote. Through that you will send the signals. There should be a something receiver which will receive the signal which you transmit. So in this port you have to connect. And the second port is telemetry. Like there are two telemetries, telemetry 1 and the telemetry 2. If you like for getting the data from the drone, you can use the telemetry. And if you are connecting any companion computer like Raspberry Pi, Jetson Nano, you can use this telemetry port. And the switch is for safety. When the switch is on, the safety is on. When the switch is off, safety is off. And like there will be like a button switch. And USB is for uploading firmware and the serial 4 by 5 you can this use for GPS and telemetry like it is an extra port if you're using multiple communication systems, so you can connect here at the ninth pin, and the 10th pin is GPS module, and the 11th is CAN like control area network. It is a communication protocol. Like if your GPS is working on your protocol CAN, so then you have to connect your GPS module with CAN port and I2C inter integrated circuit. Like if you has a compass module that will communicate with I2C protocol. So you have to connect a compass module to I2C. And here sixth pin is power, and it is for powering on this Pixar flight controller, and it will sense the how much voltage is taking by the drone. Like it monitors the voltage and current. And the 13th pin is ADC 6.6. It is a analog to digital converter. Like if you are using any sensors which will work on 6.6 volt, you can connect to this pin. So let me know if you have any doubts in the this connection diagram, like what is part and what it determines. So you can ask about that in the chat. So I can answer.
They're responding. Until now, do you have any questions, queries?
Yeah,
Do mention in chat box. make it much more interactive. No, sir.
Okay.
Great.
And let's go to software tools. Here there is a Pixar which we are using Flixark as a brain for the drone. So to set up that we need a software. Here flight control software is PX4 and R2 Pilot. These are the firmwares. So PX4 we will operate for autonomous drones and high-end operations. And for hobby thing we will upload R2 Pilot software. And for research purpose we can use PX4. And these are the control softwares which will program that flight controller, that is mission planner, Q ground controller, and APM planner, MAV proxy, and tower. These are the different softwares we will use to program this board through USB. Yeah, flight range, we calculated the approx flight time, right? Based on the calculations. Like if you need again to calculate flight time. So here it is you ask number of rotors is 4 and power drawn for the motor. Let's take it as 0.1 and the voltage of the battery is 20.2. AH of the battery is 22 AH. Here you can see that flight time is 72 minutes. So through this, you can calculate the flight time. Range, you can calculate by the pitch rate using the propeller pitch. Like how much, here you can see that in motor specification. In motor specification, if you are flying at 50% throttle, it will show that that RPM motor is 3.588. That you have to multiply with pitch rate and you can calculate the speed of the drone. Mostly when you're going with autonomous drones, we will go with up to 10 meter per second. And coming to applications, first thing you can start with security, border security, and surveillance, and rescue operations like delivering medicines. And if there is flooded area, you can drop like it's like as a disaster management and agriculture spraying and monitoring, inspection, and if there is any pipelines you can check leakage of gases and everything, and from mapping and farming. So now let me simulate for you in virtual environment. Let me simulate for you. Here I am creating a virtual drone, how it works in real time. So this is the command. So before that, you have to set up in your laptop like some installations and everything. So here I am creating an virtual drone, which is home position is 16.46, and this is the latitude longitude of the home. So here I am creating a R2 which is a quadcopter. I am designing. Here I am simulating. So if you enter, it will generate a R2. And the next thing is, and this command mav proxy is the tool, is the like you can say operating here. Master TCP 5760. This is the address which this drone is connected. The virtual drone is connected with 5760, and you are splitting that signal into two signals as two IP address. One is 50 and another is 60 by changing the last two. So if you run this, so it will generate a console. Like it's created a virtual drone here actually. So now I will connect this virtual drone to software, that is mission planner. So as previously in slides you see that mission planner is the software which is used to program the drone. So here I am connecting the drone. So the user, it will connect with address which we gave here. Here we gave output as 50 and 60. So here my drone is connected with 50. So you can see that icon of the drone, and here plan, if you want to give an autonomous plan, uh, you can like clicking here points, you can navigate autonomously. And this is the setup. Now let's see simulate the drone with commands. So to simulate the drone in autonomous mode, first you have to change the mode into guided. So you can see that mode is changes into guided, and interface also you can see here uh, guided in the left side. So now let's the take off the drone up to 10 meters. Now first we will arm the drone. Arm throttle is the command for arming the drone. So here you can check that arm. So drone is activated. So now if you give any commands, the drone will check take. Again it will disarm. Like if you are not giving any commands for 10 seconds or 5 seconds, that will turn into disarm. Like motors will turn off automatically. Then you have to arm again. Now I am giving takeoff 10 meters. When I click enter, you can see here the altitude is increasing. 6, 7, 8, 9, 10. Now are you it is visible?
Yeah, Manikanta, it's visible.
Yes, sir.
Yeah. Yeah, if you want, here you can see that drone is at 10 meters altitude. Same you can see in the console also. Here ALT is 10 meters. Now I want to land the drone. There I am saying mode land. So here you can see that altitude is decreasing. 7, 6, 5, 4 like that. You can see here mode is land. Hello?
Yeah, yeah. Yeah, Manikanta, it is visible
Yeah.
and
Now we will see navigate to some points. The drone will navigate to some points. Let's arm the drone again. Before that, you have to change the mode into guided. Arm throttle, take off to 10 meters. So now you can see that drone is takeoffing to 10 meters. So now I want to fly the drone to up this point. So like click fly to here. The altitude is 10. Okay. So now the drone will start navigating to that point. Is it visible?
yeah, Manikanta, it is visible.
Yes, sir. Yes, sir.
Now the drone has to go this side. Here now you click right click and click fly to here. Now again the drone will start moving to here. Here we are creating a virtual drone instead of a real drone. How that's working? Basically, we can write a Python code for simulating this drone. So now here in actions, there will be RTL. RTL stands for return to launch. If you click that, the drone will come to home position automatically. The place where it's takeoff. So here after it is landing, So by this way, you can simulate, like if you have any code, you can simulate with this without going to outside and real time testing the drone. So you can check here how the code is working. Now, like I want to share that like we are doing a disaster management. So for that, we written a Python script for that. And let me show that how it will work in this part. So here in terminal, while we're creating, we divided the main into two parts. One is 50 and one more is 60. Through this software, we connected with 50. So to our code, we have to connect that with 60. So now I am running this code. So this is the user interface. Is it visible? Hello.
Yes, Manikanta, it is visible and
Like if
students are
there is
responding.
there is an area like which has let's take as 50 or 70 acres of area you want to scan after disaster, after floods, 2 days after. So now first you have to create a KML file for that area. So here we are taking some examples which we created. So we created a KML file of square shape area. So here when you select this, here it is asking grid space, like your camera will have it, your drone will have a camera, so that can scan a swap width of some meters. Like if you increase the height of the drone, it will cover a long area. So he, based on the calculation, let's take it as a like 40 or 30 meters. If we click generate grid, it will generate a grid lines, like how the drone should navigate. The green line stands for navigation path, and the square path is like a boundary, and that red line is like a geofence. Like if there is any malfunction happened and the drone is coming out of this boundary, the drone will automatically come to home position. Now, when we click start mission, you can check here that drone is armed and it is taking off to here in our script, which we return, we gave the altitude of 50 meters. So here you can check that the altitude of drone is increasing from 39, 40. It will go up to 50. Then it will start navigating this path. Like this is the first navigation point you can check similarly parallel. So after reaching the first point, it will start navigating. So here the first it reached the first point and it's starting surveying. In this path, the drone will generate. So here we written the code according to the logic. The thing is the drone has to navigate with these grid lines. So the drone will travel in these lines. So if anything malfunction and anything happened, the drone is out of control. Like it's going, like it's navigating to this point. So you can see that after reaching this boundary line, which is green color, red color. So it is out of control. Then it is counting to the home position back. Like it is a safety feature for the drone that we added. So it breezes this geofence line, like it is going out of the boundary. So then it's triggered home position, home point. So the drone will come to home position and land. And like this, we can simulate our code virtually. And if everything is working fine, then we can dump the same code with in real time. I hope you understand. Hello.
Yeah, Manikanta.
Yes, sir.
If anyone
Respond,
has
guys.
any questions,
Responsive
you
chat.
can ask.
Yeah, make it much more interactive.
Yes, sir. Actually, yes, understanding, sir.
Yeah, okay, thank you. Like you can generate different, like if the KML file is hexagon, you can start generate grid. It will generate a grid in hexagonal. Like if your file is in triangle, it will generate the grid in triangle and it will create a boundary lines also. So this user interface we created for disaster management. And if you take any random plot, if you give any random plot also, it will generate the grid lines. And and if any question or any doubts, you can ask in the chat box regarding this disaster management or related to today class.
Guys, do respond, chat, ask questions, make it interactive. Monica, yes, sir. I think everyone is very interested and like they are having no doubts on drone
Uh,
technology.
okay, then let's go to the future of drones. The future of drones may be in swarm drones. Like multiple drones will communicate with each other. Like there will be a master drone and the backside drones will follow the master. And AI for autonomous decisions like path navigation. Like if there is any obstacle, the drone has to navigate avoid by avoiding that obstacle. And the flying taxis. The main future is the main flying air taxis. Now we are going to build an prototype for air taxi. It's around 200 kgs. And the next is drone delivery corridors. And the major challenges is battery life and the safety and the regulations. So let me share the work which we did. Let me just share the drones which I built. And this was the first prototype for air car. Like it's a mixing combination of a car and a drone integrated with a single flight controller. And the next is medical delivery drone, which we working prototype with autonomous. We written a script for navigation and everything.
Do spam reactions, guys. These are his own
So
inventions. Need to give
and
support, right?
next we build a hexacopter which can carry 1.5 kgs payload. Next, and last year I think, last year of the last year I don't know the inauguration of Ram Mandir.
Wow.
So we did in our college days, like we kept a flag on the drone. We navigated the path as a name of a Ram, RAM.
Wow.
And the next is we build an like own frame, which we use PVC pipes. Previously in slides, you can see the H frame. So here
Yeah,
we
yeah.
made the H frame drone and we connected the flight controller and we programmed it. And next is this was in my when I went for internship, we built a customized drone. This also carry 2 kgs payload. You can see the like stability of the drone while flying. And the next is this when in our lab, which we build approx mostly 4 to 5 drones in. And the next is this is the first working prototype we did in our first year of college, like air taxi one, like working car and drone. That was the first we did.
Wow,
So this takes approx 1.5 year from we started from basic. So it's take 1.5 year to make this small drone. And then we started remodeling it.
okay,
The our future we are planning to build like this.
great, great, great. Uh, Manikanta, like there is a question. Sir, can you
Yeah,
please explain how to plan a same thing in Mission Planner without any coding?
yeah, okay, sure. Wait 1 minute.
He want without code. He want
Yeah,
to make
without
it
coding.
without.
Yeah, without. Here I am simulating, like I am creating a virtual drone. With Mission Planner, how we can navigate, I will show. So in Mission Planner, you will have a plan. Here you can click add below and add takeoff. And here altitude you can keep for as 10 meters. Now you can draw the points. Now let's take this path, this path, this path. And at last it has to come to home. So here you can return to launch. So change these altitudes how much you want. 10, 10, 10, 10. I hope you are understanding. Now you click right and now you will right click and clear mission. Now click read. So these points will be added to your main part. Understanding? Is it clear? Hello? So, yeah. Now here in actions, here you have to select mission start and mode in guided. And now you click arm. So the drone will arm and click to action. Yes. So here you can see that the drone is takeoffing to 10 meters. So and it start navigating to this first point. After reaching the first point, it's going to next point. So like this, you can create random plots. Like if you need a survey lines, you can create the survey lines, survey grids. So after covering every point, it will come to home position. So after get come to coming to home position, it will start descending. Sir, is it clear?
Actually, he was struggling with the signal issue. The person who asked the question, he was not
Okay.
in the meet actually. That's fine. We will be sharing our recording session. He will be get
Yeah.
clarity on that.
Okay. And next is this is the testing video of that customized helicopter. And the next is flying a hexacopter. And this was the workshop we did in VR Siddhartha. And this we built for medical delivery. So there will be user interface. where the user will order the medicines. So once he ordered the medicine, order placed successfully. Now the base station will enter your coordinates. Like once you click send, it will show your location. Now the drone will start and going to that position and the drop the delivery box and it will come back to its home position. And this is an RTK, which is real-time kinematics, like which will rectify the GPS glitches. And this we tested in our college days. So this we did in on Republic Day. And this we did in time of internship. Here this will hold coconut tree for cutting coconuts. And that is my work which I did till now. Uh,
Great, Manikanta. That was literally amazing. We are so
Thank you.
glad
Thanks
to
for
see
giving
you
this opportunity.
those works.
Thank you.
And thank you for joining us, Slate Valley, for your valuable insights and valuable session. I hope everyone enjoyed your session and it was literally interactive and very amazing.
Yeah.
And any questions you can ask, guys?
Yeah, you can feel free to ask the question.
Yeah. Thank you, Manikanta. Thank you for joining us on this day. And there
Yeah,
are
thank.
lots of messages, and people are tagging us, tagging you in Instagram and LinkedIn. Do
Yeah,
check
sure.
that.
Yeah,
And
here
thank
I am
you.
sharing my details like mail ID and the LinkedIn you can get.
Yeah, Manikanta Pujari. Do check there his LinkedIn. He's very professional in drone technology. You can go through
Yeah,
his profile and do follow and ask him much more insights. And furtherly, we will be planning some sessions with Manikanta too on
yeah, sure.
regarding drone technology.
Mm,
Thank you, Manikanta, once again.
yeah, sure. Thanks for giving this opportunity.